this is our 11th MCQ. So it's again chemical calculation, and you can see there is a acid-base reaction. So if you carefully go through the question, you have some volume and concentration of NaOH, and again volume and concentration of sulfuric. Okay, so strong acid, strong base titration. Normally these reactions are acid-base reactions are completely occurring, which means until one reagent finishes, that reaction is going to continue. According to the question, now if you continue to read, you will see the solution were mixed and the total volume of the mixture made up to 250 cubic centimeters with distilled water. So that means from 50 cubic centimeters you are adding from sulfuric, and 100 you are adding from NaOH, no? And another 100 water you have added to make the total volume up to 250, right? Then what they are asking is the concentration of OH minus in the resultant solution. That means some amount of NaOH remain after acid-base reaction, and remaining concentration we have to find. Let's give it a try. So I write down the reaction. NaOH, H2SO4. You have Na2SO4 and 2 water. For balancing, I have to put 2. So then their stoichiometry ratio is 2:1. And you can see this is a completely occurring reaction. That means 100% is going to occur. The opposite of these reactions are equilibrium reactions, which are only part of the reactants are converted to products. That means some products are again can form reactants. Both the forward and reverse reactions are occurring. Okay, so to do this kind of a question, there is a method you can follow. So you can start like this: added, reacted, and remain. For a completely occurring reaction, you can follow always this method. For short, we say it as ARR method: added, reacted, remain. And if it is an equilibrium reaction, you are using ICE method. That means initial, change, and equilibrium. Okay, with the question I will explain that method also. First of all, you identify what is the type of reaction, whether it is completely occurring or it is a partial, or that means an equilibrium. Using that, you write added, reacted, remaining, and do the question. So added moles of NaOH. Here it is Na equals Cv. By now you are familiar with that, no? So 0.05 moles per decimeter cube. If it is essay question, you have to write like this. So then you have 0.005 moles of NaOH is added. So then H2SO4, you will have 0.02 into 0.05. We will have 0.001 moles. Then you can write those. So you have added 0.005, 0.001. Then reacted. Lamai, you have to understand which one is going to completely react, isn't it? For understanding of that, you can think like this. If you have 2 moles of NaOH, you need 1 mole of H2SO4, right? That means if you have 0.005 moles of this one, you need 0.0025 moles of H2SO4. But we don't have that much amount. We only have 0.001. That means twice like that. 0.002 will react from NaOH. And this one will completely react. Then it is going to be our limiting reagent, isn't it? Sulfuric. And here you will have 0.001, 0.02 like that. And then remaining 0.003 will be there. So that's the remaining NaOH moles. So then when I gave this one in my physical class, I saw some students are doing a calculation in this way. So they took this water, then they drop this water into like H plus and OH minus. So can we really do that one? No, we can't. Okay, in water, this is not a completely occurring reaction. That's the mistake, right? This kind of ionization happens, but it is very partial. So at 25 degrees Celsius, if you are having like in 1dm3 of solution, you will only have 1 into 10 to the power minus 7 moles of each. That means a very small value. It's true that water can also give you some OH minus, but when you have a strong base in the medium, you are ignoring the amount of OH minus given by ionization of water. Okay, so therefore you have to ignore that one. I hope you understand what I am telling you. This OH minus concentration is actually negligible. For the calculation, we don't use it. So now we only have to pay attention about this NaOH remaining, right? So now you have 0.003 moles of NaOH remaining, and that is there in 250 cubic centimeters. NaOH, completely ionized into Na plus and OH minus. So whatever the concentration you get for NaOH will be there for the OH minus also. So then total volume is 0.25 dm3. That means lemma is 0.012 moles per decimeter cube. And that is same like our OH minus moles, because it is 100% ionizing. So 0.01. You have to be careful here. You can see the unit is different, so therefore it's going to be a wrong answer. First one is our answer. So don't worry, Lamai, now in our exams they will not mess up with the units. Right, so that's our 11th question.